Good Tuesday morning, everybody. And I hope that you had a wonderful long weekend. Today, what we're going to do is take a look at some common tangent problems and some walk-around problems. There were actually two of these types of problems in your work from 10-1. Problem 37 was a little bit tricky, gave a few people problems, but problem 40 gave people much more problems. So we're going to take a closer look at those and some related type problems. Okay, so I hope you have your thinking caps on this morning as you're listening to this and working through it with me. All right, so Big Ideas 10.1, number 37. This problem might have looked familiar. It's called kind of a classic walk-around problem. And when you have a circle that has a polygon kind of around that circle where all the sides of the polygon or quadrilateral, okay, are tangent to the circle. Now the key in this type of problem, and you're asked to find the perimeter for this particular one, okay, and you actually know the sides, most of the sides, right? The only one you don't actually know the length of is this piece, this piece right here, okay, but you know it's the same as this piece, okay, but you don't know exactly that piece from here to here because you know that the whole side is 8.3. But actually you do know it, right? You do know that this is 3.1 also. From that theorem last week, and this is an important theorem, that from an external point, okay, the tangents drawn to the point of tangency, okay, or the segments drawn are going to be congruent. So this piece is going to be congruent to this piece. That's going to be 3 1/10. That makes this 5 2/10. Okay, that makes this 5 2/10. And now if we add all of our sides up, okay, 4 1/2. We've got this side here, right? That's a total of 6 4/10. We know this is 8 3/10. And we'll just add this up, 6 4/10. And if we add all that together, we get our perimeter of 25 6/10. All right, so that's how you do kind of an easier type walk-around problem. But I'm going to introduce you to ones that are a little more challenging. Okay, so for example, we have this quadrilateral ABCD, and it's tangent to the circle. And we know that from A to B, this whole side is 10. Okay, and from B to C, this whole side is 15. Okay, and from A to D, this whole side is 18. And at first you might think, well, I really can't figure out the length of CD. I don't know how to do that. Okay, but this theorem that we learned last week about these segments drawn from a point outside the circle to the point of tangency, those being the same length, okay, are actually really key to solving a problem like this. So this one's congruent to this, okay, and so on. All right, so what do we do in a situation like this? Well, just like we would always do, right? We might just start by saying, well, let's let one of the things that we don't know be a variable and see if we can work from there. All right, so for example, if we say that this side is x, okay, then can we figure out or write an algebraic expression for this length? Okay, and it's usually better if we try not to use another variable, right? If we can. So if we know that whole side is 10, then don't we know that this is 10 minus x? This part I have in red. Okay, and if we think about that, then if this is x, then we know what this piece is, right? 15 minus x. All right, so let's go around a little bit more here. So this part here is 10 minus x, and so is this. So that's 10 minus x. Okay, on this part, this gets a little bit trickier here, right? What's that? 18 minus 10 minus x. So you have to be really careful when we do that, right? It's 18 minus the quantity of whatever 10 minus x is. Okay, and if we think about that and simplify that, okay, what do we have? Okay, right, we have 8 plus x. All right, so now we know this is 8 plus x, and this is 15 minus x. At first, that might not seem particularly helpful, okay, except that if we're trying to find the length of CD, this length right here, don't we just have to add these two things together? Okay, and what is 15 minus x plus 8 plus x? Look at how convenient that is, right? Those x's dropped out, and so we have 15 plus 8, or a perimeter, or CD rather, of 23. Okay, and once we have that CD is 23, if we needed to find the perimeter, we certainly could. Okay, so one thing you might be thinking right now is, I chose this segment right up here, right? I chose this to be x when I started. Would it have mattered if I had chosen somewhere else? Okay, so let's just take a quick look at that and see. Suppose we chose somewhere else. What would have happened? Okay, so just to make it a little bit more a little different, right? We're going to put this AB is 10 again, and BC is 15, and AD is 18. We're still looking for CD because that hasn't changed. Okay, but suppose we were saying, okay, this is, let me let this be my unknown right here. Let this be Y. Okay, so now I know this length, don't I? Okay, 18 minus Y. So this is also 18 minus Y. Okay, so let's walk around and see what else we know, right? So if this this segment from here to here is Y, then so is this, and this is 10 minus Y, and then that means this is 10 minus Y. Oh, and here's that kind of a little bit trickier part that we have to be really careful, right? This is 15 minus whatever that number is, 10 minus Y. Right, so what does that simplify to? That's right, it simplifies to 5 plus Y. Okay, and do you see that we are, okay, got it slightly different than in the last one, but if we add these together, we're still going to have 23. Okay, so that's pretty clever. So you're going to practice those types of problems today. Another type of problem that you were asked to do is something called a common tangent problem. Okay, they're actually a good problem to have a strategy. So we're going to learn that strategy today. Congratulations if you figured it out on your own. Okay, you were not alone if you had trouble with it, and that's totally fine. That's why we're going to look at it now. Okay, so a bicycle chain is pulled tightly so that the distance from M to N, that segment, is a common tangent of the gears. Okay, so common tangent problems. Okay, this segment right here is a common tangent. We want to find the distance between the center of the gears, and we know the radii of the two gears. Okay, so basically we do know that the radii drawn to the point of tangency makes a right angle. So another important theorem from chapter 10, section 1. Okay, and if we were to draw a line parallel to that common tangent through the center of the smaller circle, okay, a line parallel, wouldn't we know that we made a right angle there? Okay, if it's parallel to the 17.6, the common tangent, then it also has to be 17.6. I wish my picture was a little bit bigger here so it would be easier for me to draw, but okay, I'm going to say that's 17.6. Now this 4 3/10 is pointing to this whole radii, right? But in a rectangle, isn't this side the same length as this side? So that's going to be 1 8/10 inches, right? So now don't I know that segment length right there? Okay. And you are absolutely right if you said that it's 1 5/10, because that's the difference of 4 3/10. Subtract 1 8/10. Okay, so that little piece is 1 5/10. All right, so how does that help us? Well, if we look carefully, okay, and again, it would be easier to see if my picture was a little bit bigger. So I'm sorry I didn't make it a little bit bigger, but okay, there we have a right triangle. Okay, where this distance between the centers that we're looking for is actually the hypotenuse of our right triangle, isn't it? Okay, keep in mind our right angle is over here, so this length from the centers of the two gears is our hypotenuse, so therefore 17.6 squared plus 1.5 squared must equal c squared. Okay, we want that rounded to the nearest hundredth, so when we do the computation here, we're going to get c equals 17 78 hundredths inches. All right, turns out common tangent problems are not so unusual. Okay, and actually following this procedure will always work whether you have a common external tangent or a common internal tangent. Okay, so I'm going to go over this standard procedure. Okay, and then you're going to perhaps have to go back to this for when you're working on your practice problems today. Okay, this will work with both internal and external tangents. We just looked at one with external. Okay, these are the steps. First of all, make sure you have drawn the segment of centers. Okay, so the segment joining the two centers of the two circles. Make sure then that you draw in the radii to the point of contact. Okay, so draw in the right angles. So to the point of contact with the common tangent. Through the center of the smaller circle, draw a line parallel to the common tangent. Okay. This line, and this is important here, this line will intersect the radius of the larger circle. Okay, we may have to extend that radius of the larger circle and to form a rectangle and a right triangle. Okay, once we have that, we're going to use the properties of a rectangle, that all four angles are right angles and the opposite sides are congruent, and the Pythagorean theorem to figure out our answer. So let's take a look at one more. A circle with a radius of 8 centimeters is externally tangent to a circle with a radius of 18 centimeters. Okay, so these circles should be touching. Okay, I had a little trouble getting them to touch exactly, but okay, but you see here. So if I take this circle, maybe I call this circle P, and this circle over here, maybe I'll call that circle Q. Okay, let's see. And do I know how far apart Q and P are? Well, actually I do, don't I? Okay, it didn't tell me exactly how far apart, but I know what the radii are. Fix that. Okay, I know this is 18 and this is 8, so I absolutely do know what QP is. Okay, and then I want to find the common external tangent. So in this case, that's going to be here. And again, when it touches at one point, and when it touches at that point, okay, it's going to form a right angle in both of those. All right. I'm going to clean this up a little bit, my diagram here. Okay. Just to try to make it clearer for you. So that's 8. And I call this circle P, so I'll put my P up here so it's a little bit out of the way, and this one Q. All right, so thinking about the steps once I've drawn it again. Okay, I am trying to find the length of this common external tangent. Let me call this A and this B. Okay, so the length from A to B. All right, so let's go back and see what we've got here. Let's see, we've done step 1, draw the segment of centers. We've drawn the radii to the point of contact and drawn in the right angles. Okay, step 3. Through the center of the smaller circle, draw a line parallel to the common tangent. Okay, through the center of the smaller circle. All right, so here's our smaller circle, and we want to draw a line that's parallel to our common tangent. So we're going to go like that, make it so that it looks parallel. We have a right angle, we have a right triangle now. All right, so let's think about what we know. And sometimes we may have to extend a radius in order for it to intersect, but this is an external tangent, so it actually intersects right here. Right, so if, let's see, so if I know the radii from of circle P is 8, don't I know the length of PB, that rectangle? Okay, I sure do. I know it's 8. Okay, and I know from Q to A is 18, right? So if this is 8, oops, my diagram didn't come out quite to scale, did it? Okay, but that's okay. It will still work. Okay, so this part here, what's that going to be? Right, 18 minus 8, or 10. Alrighty, so do we know the hypotenuse of this right triangle? We sure do. Okay, it's this length right here, or 26. So we have, in this case, 10 squared. Let's see, we don't know this length, AB, so therefore we don't know this length. But we can call it x, plus x squared is going to equal 26 squared. Okay, now you can use the Pythagorean theorem to figure out what x is going to be. Okay, x should come out to be 24, and because it's centimeters, 24 centimeters. Okay, think about this and justify to yourself too, okay, that if I were to do my common external tangent on this side, let's call it CD, okay, would that have to be the same length as the distance from A to B? Okay, and absolutely you would, and you can go ahead and try to prove that to yourself. All right, so now go ahead and try some of those problems. And see how you do. Okay, I'll be looking for good examples to post as answers to those. They are challenging. They're thinking problems. You've got to draw some good pictures. Okay, so have at it and have fun. And I'll see you for our live class tomorrow on Wednesday. Have a good one.